Thanks everyone for tuning in this morning. As Susan mentioned, our topic of conversation today is seismic design of solar arrays on flat roofs. And the intent of this presentation is not necessarily to be just a how-to, but also to describe some relatively recent developments in the field of design of solar arrays on flat roofs, which is an area of structural engineering that in structural engineering time is relatively new and evolving relatively quickly to keep up with the development of solar technology. So it's an exciting area that Andreas and I have been excited to be involved in, and we're looking forward to sharing some contributions, not just our own, but of many people in this morning's webinar. So for context, as Susan mentioned, this is the second in a series of webinars on this topic. Today, a focus of our conversation will be the document on the right, which is a document produced by the Structural Engineers Association of California, SEAOC. Both of these have to do with design of solar arrays, and as Susan mentioned, previous episodes of this webinar series discussed wind design with Ron LaPlante and Jason Erickson. So before we get started today, I just wanted to thank Ron, who's presented both of these sets of information in various forums. So some of his slides made it into this presentation today. Also thanks to Joe Maffei and Rob Ward, who contributed several images that we're going to be looking at today. Before we jump into the details, I just wanted to sort of remind ourselves of a point to take away here. And that's that often we think of wind and earthquake design as just lateral forces. And we know that that's not right. We know that that's a simplification that we use for design. But it's maybe a little bit less true for solar arrays even than it is for buildings. And so last time, Ron and Jason talked about wind design of arrays in terms of pressures that act on modules, and that's affected by various aerodynamic properties of buildings and arrays and swirling of winds. Today we'll be talking about earthquake effects on arrays, so it's just a good point to start to remember that an earthquake is when the ground shakes, and that works its way through a building and then can have various effects on a solar array depending on the characteristics of that array. So with that, we'll start to jump into our presentation here. As Susan mentioned, we're breaking it into two parts. This first part I'll be covering on rooftop solar arrays and the SEAOC PV guidelines. And then in the second part, Andreas will discuss response history analysis and shake table testing. For the first part, I'll begin by just talking about different types of solar arrays and maybe focusing the scope of which arrays this presentation covers and which arrays the SEAOC PV documents cover. Then we'll talk about concepts of earthquake effects on solar arrays. And then the meat of this first part is discussing details of the SEAOC PV committee work and specifically related to the seismic design guidelines. And then we'll touch on some next steps. So, solar arrays. This is, excuse me, this is a solar array. This particular array consists of about 200 modules. And you can see it's located in the desert. It sits on the ground, and these modules are grouped into relatively large panels where the high end is several feet off the ground. This is also a solar array. It's a much different type of solar array. It has, excuse me, it has many more modules, and in this case, the modules sit within a few inches of the roof surface where they're located.